I want to talk about integrating AI tools into Java programs. The problem right now that we're faced with as Java developers, assuming you're primarily a Java person, is that if an AI tool has an API at all, it's either Python or JavaScript, sometimes TypeScript. They rarely provide any kind of Java API. But if they provide a REST API, and most of them do, hey, we've been dealing with RESTful web services in Java for years, no problem. We can work with that. So I'm going to talk about that, how to integrate with these services. Now, there's a couple of major, I was talking to a couple of people earlier, there are a couple of major frameworks in Java on the way. LangChain for J is one, and the other would probably be Spring AI. Both of them are pre-version 1.0. In other words, you can use them, but don't be surprised if they undergo significant changes in the next whatever amount of months, something like that. Also, the problem with working with a framework is if a new capability comes out, and this stuff's changing all the time, you have to wait for the framework to integrate it. Whereas if it's just a RESTful web service, they all want you to use it right away. There's no reason you can't do that, and that's what I want to talk to you about. Now, I just put this at the beginning just because I wanted to let you know that when I use my IDE, I use IntelliJ for pretty much everything, and I have two AI tools built right into IntelliJ that I use. I use their AI assistant, and I use GitHub Copilot. I found that both of them are helpful for different reasons. GitHub Copilot is very good with code suggestions. I find that's quite useful. It's pretty good at generating test cases, things like that. Whereas AI Assistant, the thing I love about it is it generates commit messages for my repository, and I hate writing commit messages, so I really like that. I use that all the time. Also, AI Assistant, when you get a stack trace in your output, not that you ever get a stack trace in your output, your stuff always works all the time, but you know how your coworkers are. They write terrible code. It puts in a little button that says explain with AI. 9 times out of 10, that's pretty useless, but yesterday it saved me. So, every once in a while, it can be very useful as well. So I'm just letting you know that's there. That's not what I'm going to be talking about in terms of the code. What I'm going to do, though, is, the one thing I like to think I bring to the table here is I don't work for any of these people. I'm not trying to be a spokesman for the vendors that are trying to market anything. This is my own experience based on what I've found as somebody independent who basically just likes playing with these things as though they were toys. Now, I will show you the OpenAI API, that's ChatGPT, and the Whisper model, which is actually where we're going to start. That's their text to audio and audio to text and everything. And DALL-E 3, maybe we'll make a couple of images, something like that. Mistral is the really interesting product out of France. The group is based in the Paris area. And what's interesting about Mistral is that they actually use the same API as OpenAI. So if you've got one working and you want to use the other, you just change the endpoint and get a key, but that's the idea. Gemini is completely different. That's the one from Google. If you look at most of the Gemini documentation, they're trying to persuade you to use their cloud product, their Vertex AI, or API, I should say, as part of their cloud product. And I got it working once, but it's always a struggle for me to get the authentication stuff working on that and everything. I'm just going to use it directly. I just access it without, from my own machine without going through the cloud intermediary, and I'm fine with that. Finally, Anthropic, well, not finally, Anthropic is the one that was the offshoot of the OpenAI team. There's a few people that left OpenAI and formed their own company. They create that Claude family of products. Claude 2 and now Claude 3, which has Haiku and Sonnet and Opus. And in fact, I don't know if I'll do it today or in tomorrow's talk, which is focusing more on using the Spring framework. In one of them, I have Haiku write a haiku and have Sonnet write a sonnet and Opus write an opus. And they are, and I apologize ahead of time for my sense of humor, but that's where I'm going to go with that. However, I do want to show you something from that, which is the vision model. Vision model in any of these is a model that looks at images and tells you what's in it. the capability shows all kinds of potential, but it's very limited at this point. The reason I want to talk to you about it is not because I'm saying, oh yeah, go use this. I want to show you that by using the latest features in Java, by using sealed interfaces and records and pattern matching for switch, you can make an API that works with both the chat model and the vision model together and keeps the code nice and simple. So I'll definitely be talking about that in the Spring Framework talk tomorrow. That's the difference between the one now and the one that I'm doing tomorrow afternoon, something like 1:30 or whatever. That one is going to use the Spring Framework without using Spring AI, just basic Spring stuff. And I may do some of that today, just if there's interest. What I'm mostly going to focus on today is not using any framework at all. Everything just saying, let's just use the raw tools that come with Java and see what we can accomplish that way. But again, just because that stuff with the advanced Java features is so easy to do, and I had it set up with Spring, I may show you that as well. Now, the fifth of the big five, if you will, I mean, if these are the four major competitors out there right now, the other one that I'm a big fan of is Ollama. Now, there are, I don't know, 3 or 4 different products that allow you to run large language models on your own hardware, on the local machine. What I like about Ollama, which is at ollama.com, by the way, it's really easy, is that it comes with this tiny little web server that runs on your machine. So not only can you download an open source model and run it on the command line, you can access it programmatically with an API. And the API is particularly simple. So I'd like to show you that as well. I really think they've done a wonderful job with that, and that's actually how I access things like Llama 3. You know, Gemma is the small one from Google, and Phi 3 is the one that came out from Microsoft yesterday morning, and yeah, I've got that working because, again, it's just another model inside of Ollama. I didn't have to change anything, just add the model, and I'm ready to go. It was all very simple. So they all run on your local host on port 11434 by default, and they also have so-called uncensored models there, which sounds dramatic, but all it means is that they don't have the same guardrails that the commercial tools have. They're not as worried about getting in trouble for everything, you know. They're not completely uncensored, and they don't generate images or anything, but you could ask them awkward questions and you may get answers. You know, I sometimes ask things like, you know, how do I break into a car? You can't ask ChatGPT that. It'll go, no, don't do that. That's illegal. It's like, I know. Well, what if I want to break in my own car? I lock my keys in my car. How do I break in? You know, that's still not a good idea. You should contact the police. No. I want the uncensored model. Okay, well, get one of these sticks, you know, you put in there, and at any rate, they walk you through it. So that's available in the Ollama system and in other tools like it. But again, this is the one I happen to be fond of. Now, let me just summarize a few points, and then I'm going to spend most of the time today going through code. You know, developers want to see code, and that works for me. So again, the point of view I'm taking is that from a Java point of view, these are all just RESTful web services. And we know how to access and submit messages to RESTful web services. So all we need is a networking client to send a message to and they all work with either get or post. You don't generally, I'm trying to think if I've ever seen a put or a delete. No, I really haven't. I mean, they all are get or post, and the get models are very limited. It's usually just finding out what models are available, and everything else is a post. So we'll use post messages for everything. And now, of course, Java has a networking client built in. So we'll use that. And of course, you need to be able to generate and parse JSON data, JavaScript object notation. Java does not have a JSON parser built in. And from what I understand, there's none planned. So we have to pick something. And what I generally have done is I picked Google's JSON when I'm doing it on my own. And then in Spring, they've got Jackson. So I worked with both of them. One of the reasons I like JSON, as I'll show you, is that if you use the builder, you can make it so it automatically converts from camel case in Java to, quote, snake case in JSON data, all lowercase with underscores. That you can set on the builder, and then you don't have to map the individual properties. With Jackson, I haven't been so lucky. But with JSON, it's really easy, and I'll show you that. Now, again, I'm going to use the HTTP client in Java. There's been a slight change on that between Java 11 and Java 21. The HTTP client API was added in Java 11. It has not changed substantially since then, but in Java 21, they made the HTTP client implement the auto-closable interface so that now you open it in a try with resources block. Prior to that, you just don't, and you could close it explicitly if you need to, but generally you don't even need to. It's just, again, we're making individual requests, and it tends to be fine, and they don't take too long, although some of the things you ask it to do can be fairly time-consuming. It might take a couple minutes to generate an image. It depends, especially if you get into video. Now, in Spring, of course, they have 4 different HTTP clients, and I'll go over all that tomorrow. But if I do show you an example today, the one I'm going to show you uses those HTTP exchange interfaces. The idea where you just write an interface and put in your methods annotated with like get exchange or post exchange. You set up a couple of beans to implement it for you, and you don't have to write any of the associated code. It's really slick. So I'll definitely I'll show you that a little bit today, and I'll really get into that tomorrow if you're interested. Again, I mentioned the JSON parsers. The interesting issue with parsers is that you need them to understand what you map the request to, and I'm always going to use records for that. This is one of the, it's not really an issue exactly. I was going to mention, I was talking to someone earlier about LangChain4j. LangChain4j supports Java 8, which means they don't know from records. But that's not really true. They do know records in your code if you're using Java 17 and above, but internally inside of LangChain4j, it's all Java 8 code. They want to support everything out there. I like records because records can be nested anywhere. They can do anything I want. They have these cool things called compact constructors, which a lot of people are not familiar with. I'll show you that too. But I use that to map my input and my output data. So the key is to have a parser and a generator that understands Java records. Fortunately, Jackson understood them practically from day one. That is the one that comes with Spring. They know all about it. JSON, the one I prefer, didn't figure out records until about a year ago last summer, something like that. It's remarkable. It took remarkably long for that to get worked out, I thought. But the problem with records from a parser point of view is records don't have default constructors and records don't have setter methods. They're immutable objects with the external constructor like that, the canonical one. So you need a parser that understands that. And fortunately, they all do now. So it doesn't really matter what you use. You should be fine on that no matter what. Now, I mentioned Mistral and OpenAI have the same API, so it's just a question of switching endpoints. The other thing I should mention, though, is you're probably familiar with the fact that practically every AI tool in existence costs $10 to $20 a month, right? They all want that sweet, sweet subscription revenue. Well, as a programming model point of view, that doesn't come up. That's completely independent. If you have a subscription to ChatGPT, doesn't matter, doesn't make any difference. If you want to access it programmatically, you have to go to their site, register, put in a credit card, because every one of those services is pay as you go, basically pay per request. But the costs are very, very small. At least I believe they're really tiny. I mean, the general rule, I have a link later to the actual pricing page, but the way OpenAI works, for example, is that it's $10 per million input tokens. And what's a million input tokens? Well, let's do it this way. 1,000 tokens is about 750 words. If you were building a prompt and wrote 750 words, that's about 1,000 tokens. You might write 750 words, but that's a lot. Honestly, most prompts are 100 words or less. So now we're down to fractions of a cent. Because if $10 was a million, then $1 is 100,000, and 10 cents is 10,000, and then 1 cent is 1,000. So I'm doing this in US dollars because that's how the prices look on the page for me. So 1 cent is 1,000 tokens or 750 words. And I usually don't come anywhere near that. So I'm figuring fractions of a penny. To work as a developer, not putting it in production, but just to work as a developer with this stuff, I'll spend 10 cents maybe. preparing a talk like this, you know, or in a week, in a month, I might spend a couple of dollars, you know. So it really is not a burden if you're just developing. At least I'm hoping it's not a burden. Putting it in production and having tens of thousands of users and using it over and over again, that's where the costs add up. But then you can get into that if you decide you want to. So again, I do want to look at this idea of combining records and sealed interfaces and pattern matching for switch, all the latest cool stuff in Java, and how that enables certain really cool features. So I'll get to that in a moment. I mentioned the records. I do want to show you the compact constructors and the image models too. But what I want to get to is this part. The easiest feature of all, believe it or not, to demonstrate, to start with, is text to audio for OpenAI, because what I have over here is the section of platform.openai.com. Let me magnify that a bit. So this is the speech to text section on platform.openai.com, and it's the audio API, and there's only two endpoints, one called transcriptions and one called translations, and they're basically identical, by the way. All you do is change endpoints on what you're sending in. But that one is, oh, I picked the wrong one. I do want to talk to you about speech to text, but right now I'd rather start with the other one, which is text to speech, because that's even easier. Turn text into lifelike spoken audio. And by the way, I'm going to give you a link to more than one GitHub repository that has all this code in it. I just forgot to put it at the beginning of the slides, but it is at the end of the slides. So I'll give you an opportunity to see that. So this is the one has a speech endpoint, and they call it TTS for text to speech. And the idea is you send in text, and it generates basically an MP3 by default, which you then download. Now, the one thing you need to know, and in fact, I think you can more or less see that, right? They're demonstrating a curl request, which is how you know they've got a REST API, which knows that means, okay, I can do this. So the endpoint is at audio/speech. You have to put in your key. Now, the convention that everybody seems to have adopted is when you get a key, add it as an environment variable on your system. In Java, the system class has a method called getEnv, G-E-T-E-N-V, all lowercase, and you just put in the name of the environment variable and it downloads it, and that way you don't accidentally check it into source code control or whatever, you know, and it gets it out just fine. So when they say, oh, you need to set an authorization header with the bearer and it's that key, that's what we have to set up, is that header. The content type, it sometimes is important, but it's always a good practice to set the content type and the accept header. Here, for some reason, they did not set the accept header. The content type, of course, is what you're sending. The accept header is what you're getting back. So what they're sending in this case is a JSON object that this is what I mean by simple. All it has in it, that doesn't help, is a model, and there's only one model. There's TTS1. Okay, there's also TTS1 HD for high def. I can't really hear the difference. TTS1 seems fine to me. And then an input, which is the text you wanted to generate an audio file for, and then a voice. And the output is the MP3 file coming directly. So we do have to model the input with a record, but the record's almost trivial. And the output, we don't even need a record. It's just giving us our binary file. We just have to be able to deal with binary output. So the thing about the voice options is that you have 6 that are available, and you cannot change them, you cannot tune them, you can't correct anything. It's just you get what you get, okay? But they all work. To give you an idea what they sound like, we did hook up the sound here, so let's see if that works.
The sun rises in the east and sets in the west.
Yeah.
This simple fact has been observed by humans for thousands of years.
So that's one of them, and you can pick from among those choices. So it's 1, 2, 3, 4, 5, 6 models. I happen to like the shimmer one.
The beach was a popular spot on a hot summer day. People were swimming in the ocean.
No, that's not the one I was thinking of. I forget which one I was thinking. Maybe Fable?
The library is a quiet and
Yes.
peaceful place where people go to read, study, and learn.
Nice English accent. You know, I kind of need that for this sort of nonsense. So at any rate, the output files are in all these forms. And the one that comes up by default is, as they say, the default response format is MP3. But other formats are available, and they talk about the different ones. Now, when I accidentally went to the speech-to-text model for transcription. That one, there's a bit of a constraint on it. You can only upload 25 megs as your audio file. And that's not a lot. That's a couple minutes of audio. So what you have to do if you're longer than that is split it up. And what I have, because Java turns out has a library that knows exactly how to deal with WAV files. The javax.sound package, javax.sound.something or other, has classes in it that will let you split up WAV files into 20 meg chunks or whatever. I use 20 because I don't want to hit that 25 meg limit. So I wrote a class, and it's in my GitHub repository, that divides things up into chunks, and then you submit them one by one, and you use a little prompt to connect them together. If we have time, I can show you that, but it's in the GitHub repository. Now, this supports all the following languages, and I note that Hindi is in there, so that's good. But there's probably, I don't know, somewhere between 50 and 60 languages around the world. Now, to show you how I do this, here is my text-to-speech class in my GitHub repository. So there is the endpoint, the one they were just talking about, the TTS URL, and that's how I retrieve my API key, exactly as you'd expect. Also, I learned very early on when playing with these things to set constants for the models that I use, because there's nothing more annoying than using an underscore instead of a dash and getting a very weird error. And it doesn't tell you, hey, there is no model with that name. It's some bizarre error, you know? So now I set up constants for that sort of thing, so I don't have to worry about it. Now, again, if you're thinking a framework should do that, frameworks will. This is just, I don't have to wait for a framework. In fact, this exact example is something that none of the frameworks I know of support yet. They're all into getting the chat working, or maybe image generation. And I'm like, well, what if I want to generate audio? It's like, yeah, we'll get there. Well, I'm doing it now, you know? That's the benefit to knowing what's going on under the hood here. So now this is what I meant by JSON having a builder, and the builder has a neat little property, which I'm not using, called set field naming policy to field naming policy dot lowercase with underscores. That was GitHub Copilot making those suggestions, as you saw across. Many of you are familiar with it, no doubt. I didn't need it in this case because there's no camel case in those properties. Remember, were all just simple lowercase words, but that's how easy it is to put in there if I wanted to. Now, in order to get started with this, I made a request. So this is my record that maps to the required properties as well as some of the optional properties. So this model, that's the one you got to specify as TTS1 or TTS1 HD, and the input is your text you're trying to generate audio for, and it has a length limit, and then a voice and a response format and a speed. Now, because I didn't set that property on the builder till right now, this was my workaround. JSON has a property called, or an annotation called serialized name, which says, oh, when you see response format in my Java code, it's response underscore format in the JSON data. You know, so you can either annotate the individual ones, or you could just set the property on the builder. In this case, because I had one property, figured, now I'll just say it. You know, now the other thing you might notice here is that I have a class called voice and a class called response format, because remember there were only 6 voices available, and the response format was, remember, the MP3 or whatever was coming out. Well, naturally enough, what I did with that is I made an enum out of it. That way I don't accidentally pick one that doesn't work. And this time, rather than build a custom serializer, which I've done in other cases, I just put the serialized name in all of them to convert the uppercase to lowercase. See, the builder will let me convert camel case to lowercase, but to do uppercase to lowercase, I had to be a little explicit about it. So there's my 6 voices with the serialized names. I also made a little method to grab a random voice, you know, just one out of it in case I want one. Then the other one, There. The response format one, let me keep that around and now go to this. That's the one that had all those different response types in it. But here's the fun part, and not a lot of Java developers realize this. Lots of people know to use records, and it's got a toString method auto-generated and an equals method and a hashcode method. This little funny looking thing here is called a compact constructor. This is the canonical constructor. See, the braces, or the parentheses rather, come before the curly braces. Normal constructor. This guy doesn't even have parentheses on it. Isn't that weird? It just looks funny to a Java developer. What the purpose of a compact constructor is to either transform the input data or validate it. So remember all those constraints I mentioned about how the model has to be one of those two and the input has a length limit? This is where you do that. If the model's not valid and I've got a constructor below, I've got a method to check that, then I'll throw an illegal argument exception. Or if the input's not valid, if it's null, blank, or too long, or if the speed doesn't fit in the range. And down here you see I have these private methods to say, oh, on that input, if it's not null and it's not blank and the length is less than 4096, then it's valid. So you could put in any authentication you want. And if the model matches one of those two, we're good. And if it doesn't, we're bad. Or again, this is something that's easy to do in a record, which I didn't know when I first started playing with this stuff. So you see how that makes it much more likely to get this stuff to work properly. So now that you've seen the request, again, I don't have to do anything for the response. The response is a binary file. All I have to do is figure out how to save that binary file. So I take my request and I serialize it to, using JSON, to a JSON object. And in my HTTP request, I make a new builder, set the URL, set my authorization header, set the content type header, and this is how you do a post request inside Java's HTTP builder class. You need a body publisher and say what you're sending. I'm sending that JSON string as a string in the body, and it'll automatically put it in there. And when you say build, now I've created the request. I haven't transmitted it yet, I just created it. Now, one thing I have to call to your attention, I think I said it earlier, but I'm going to mention it again anyway. With the HTTP client in Java 11, it was just the way it stands. There was nothing special about it. Now, in Java 21, it implements auto-closable. So you see, I'm actually using it inside a try with resources block here. That's new. So if you're going to run this code from my GitHub repository, I'm using Java 21. If you're not on Java 21, just take that out of the try with resources block and it'll work on Java 11. Actually, you need 17 to run any of this code. Okay, but let me point out what we're doing there. So now what I'm doing is you call the send method. Now send is synchronous. I could call send async and get back a completable future, but this is generally fine for me. You send the request and then you use one of the body handlers to say what you're getting back. Now when we look at chat, you'll be getting back strings. But when you're doing text to speech, you get back binary data, and fortunately there's a method called ofByteArray. There's also a method called ofFile too, but I'm just going ofByteArray right now. I'll get the byte array back and then I'll save it myself. So all you have to do is extract it from the body. I have a utility method I wrote to save it to a file, and that's fine. And then I can look at the response and check the headers and print out the headers and just return the body. And that's the entire code for doing it. And it looks complicated because there's a builder, a couple of builders involved, and builders just look verbose. But all it is using the parser and using the networking client, going there and getting the answer back. Now, before I demonstrate it, I want to tell you that I went looking online and found an audio player in Java that plays MP3s. Believe it or not. It was from a project called, let me magnify this just a moment. There. It's from a project called JLayer. I mean, the project's like 10 years old or more, and it still works. just fine. Thank goodness for Java backward compatibility. So I added it to my class path, and now I can go send the request, get the MP3 file, wrap a byte array input stream around it to a buffered input stream, and that's the input to the player, and just call play. See? So if I look at my test class here, then I do have one where I just generate audio, and that saves it too, but I'd rather do the one that actually plays it as well. So I'm going to try TTS1 HD, although again, I don't think the HD matters. I did use a text block. I mean, thank goodness for text blocks, that way I could put quotes and apostrophes and everything in there. I don't have to escape anything, that's nice. I don't know why, but I guess just for the output purposes, I decided to replace all of the extra spaces with just an empty string, so I don't get a bunch of carriage returns in the output. Doesn't affect the audio at all. That's fine. I picked a voice, and now I'm going to play it as well. That's the generate. Wait a minute. This is the one. That'll do it. So, all right, let's run that and see how it goes. I'll keep my fingers crossed. And we'll see. Yeah, so it saved it. Did it play yet? Not yet. It should be coming. The demo gods were not with me, but you get the idea. Okay, so now let me jump to something a little bit more interesting. That stuff with the different records and sealed interfaces and everything. So for this one, what I'm going to do is I'm going to go to Ollama, okay? Now this is Ollama, which has a simple installer for both Mac and Windows and for Unix scripts and everything. It works just fine. And then you wind up downloading individual models like Llama 3 or Phi 3 or Mistral or what have you. And if I go back to the GitHub repository, then what they have in here is a link to the REST API. So let me skip down to where it says REST API right here. And in fact, you could see all they're sending in is a model and a prompt, okay? But if I go to the actual REST API, then what I'll show you is that if I scroll down a bit, we have model and prompt, but we also have model, prompt, and images. See the images section there? And what it contains inside there is a base 64 encoded string representing the image itself. And if you're thinking, how do I turn, an image into a base 64 encoded string? In java.util, Java has a class called base 64, and it's got methods called getEncoder and setEncoder. And all you have to do is encode it, and you put the byte array in there, you get back the string. And if you get back a string, you want to decode it, you could use the decoder too. So really useful. But you see how similar those two models are? Just one has an extra images block and the other doesn't. Okay, so this one is in my repo having to do with Spring stuff, but I want to show you this time. I'm doing this one because it's particularly simple. I want to make a text request and an image request. In both cases, I want to go to this generate endpoint. There's a generate endpoint and there's a chat endpoint. I want to do the generate endpoint because it's really simple. So there's my model, there's my prompt. Also, I want to turn off the streaming property. I don't want to get back one word at a time. I want to wait and just give me the whole response. Because otherwise the first response is and then you have to wait for the next one and the next one. I'd rather just get the whole thing. So there's my generate text request, and here's my generate image request, which takes a list of string, those images, those base 64 encoded images. And you could go ahead and just send one of these request types and get back a response, which I have down here. See, this is all the interesting properties in the responses. Just the model, when it was created, the response itself, when it's done, duration, and something about the eval count, which you're running on your own machine. I don't care about that, but there it is. But notice what I did. I added an interface, but not just a regular interface, a sealed interface. Sealed interfaces only can be implemented by, quote, permitted classes. So I'm going to permit just that text request and the image request. I put the properties in that are in common. Remember, that's in an interface, so you use that syntax for it. They both have a model, a prompt, and a stream, but it doesn't really matter, but I put them both in. And then these are the only ones implemented. You may notice that all these classes and everything are public. How come they're not all in separate files? This is a convention that I've kind of adopted just for my own use. When I'm building these records, I really want to see them all together. I don't want to have to jump from file to file to file to see them. So I made a class called Ollama Records, and these are all interfaces and records defined inside. And that means that when I use them, I do a static import of this class. Just import static Ollama Records.star, and then everything looks clean and they all look like they're separate. You can always move them outside and make them all public and up and top level if you want, but this works nicely for me. So now this one again is using Spring, and you see here I used to have two separate methods, a generate method that took the generate text request and a generate method that took the generate image request, both of which create a response, even though they're both going to the same endpoint. By using the sealed interfaces, I could say, no, I'm just going to send a generate request. That's the interface type. And it doesn't matter which one I send. And it works just fine. And in fact, in my service over here, when I do this, because that's the other thing, and I'll talk again more about this tomorrow in the spring talk, I usually make the interface and keep it as simple as possible. Here's the input, here's the output. And then in the service, I pre-process inputs and I post-process outputs, just to make it simpler. So here, for example, I auto-wire in the interface into the service, and if I want to do generate here, this is pattern matching for switch. It's a switch expression. I'm passing in one of those requests, and then it says, if we're on an image request, call it image request. I'll just log that I'm generating an image and then call it. But if it's a text request, I'll say that and then call it. And this is highly contrived because I'm sending it in both cases. If I wasn't logging something different, I wouldn't need this. But I wanted to demonstrate for you what the process is, what it looks like. And you see how neat the combination is of records with the compact constructor, with the sealed interface, with the pattern matching for switch, with the switch expressions, all that works together. And then when I want to call it in my test case over here, then this is generate with text, and all I do is call generate. And this is generate with an image request, and I just say, what is in this image? And here's what the image looks like, by the way. My happy leaping robot. Yeah, okay. I generated that with DALL-E, which is why, and like most things with DALL-E, it's just on the edge of creepy, But okay. And by the way, I'm using a JUnit 5. Oh, it closed it again, didn't it? I hate when it does that. There. I'm doing a parameterized test because the lava model with Ollama, use lava instead of llama, get it? Because V for visual, that's the visual model. And they have another model called, you might as well keep the puns rolling, baklava. Right, on that. Yeah, I know, isn't that awful? But if I run it now I'm not trying to do anything in parallel, I'm just executing it. What it's going to do is serialize the image and upload them into the system. I didn't show you the serialization part, but that's easy enough to do. And then it will give me back the explanation of what's in the two images. And again, don't expect anything profound. The goal with the vision model is that you could take a picture of something and then react to what's in the picture, Like the joke use case they talk about is you open up your refrigerator and you take a picture and say, give me a recipe that works with the ingredients I have on hand, whatever's in the refrigerator. I would say the risks of that working, the probability of that working is pretty small because it does detect things that are small. I mean, they're clear and obvious. But if you got two things next to each other or one behind the other or just parts of one and the other, and you got a refrigerator, stuff's all over the place. Yeah, you're asking a lot, for it to figure it out. At any rate, so the lava one said, this image shows a robot standing in a verdant setting with green foliage and trees around, etc., etc. And the baklava one kept it simple. 3D robot celebrating and surrounded by green plants, So it works. And again, I'm more interested in the process here than the actual output on that. Okay. Now, let me hold off on the RAG stuff. So you see, you map the JSON data to records. You set up a networking client and you're done. And you can also, like I do recommend, you set constants for various things. You set enums for various things. You put in the compact constructor to enforce any constraints, because that's an advantage we have over the Python API or the JavaScript API. On those APIs, they write out in a comment what the constraints are. Here, we can put it right in there with methods that get enforced during the compact constructor automatically. Really nice. I showed you the Ollama records and the text-to-speech. For Claude, things got a little bit more complicated because there were, in fact, 3 different types of inputs. There was a success, there was a failure, and there was a chat and a vision and an error. And I wanted to map all 3. So that if I got an error, I could actually interrogate the error as well. And I have that available, but I'm not going to do that right now. So again, these are the different properties I'm talking about inside of Java. Text blocks for transmitting data, and the great benefit, again, is you don't have to escape anything. And you can even put JSON data right in the text block, and it works just fine. So for example, if I go now to the first one that I was talking about, here is my class to access ChatGPT now, the standard one. And that one uses chat/completions. And this is a separate one, which is the only one I know of that supports a GET request. In all of these models, you're going to have to ask for a model name. You're going to have to use a model name as part of your request. For Claude, it's the Opus ones or the different Claude 3 ones. For Ollama, you've got a dozen to choose from. For ChatGPT, you've got GPT 3.5 Turbo and 4 and GPT 4 Turbo and many others as well. So this endpoint will give me the list of models. And you'll see how this looks the same. Now you see this one I have not converted to Java 21 because I still have my HTTP client as an attribute here. So when I say list the models, it just does a create, set up the formatted authorization header, transmit the request, and this time instead of getting back a byte array, I just say, hey, it's a string, convert it back into this model list, and to see what the model list looks like this time, you see, oh, I made these top level. Okay, that's fine. I'll show you that. So I have a model list, which is a string and a list of model. And then here's model, which has an ID and a created and an owned by. I overrode the toString method so that when I print out the created, I converted the Unix timestamp to a Java date time. I couldn't resist. So that's what this is. It's a little method to convert it from a Unix timestamp into a local date time, and the toString method was overridden just to show that. So if I go to ChatGPT test, then here I can list the models, and I'll tell you about it while I'm running it. So I just list the models as a get. I assert that it's not empty. And then here's the annoying part. You have to dig down in to find the response that comes back. This is why you might want to put a convenience method in that extracts the response from the overall output. So this one, you see what I did is I sorted them by the ID, which is the name of the model, mapped them to their IDs, make sure they're all distinct, convert them into a list, and then just print them out. And now you see that's why they're alphabetical. But there's the DALL-E models, there's the various GPT models, there's the TTS models, and there's the Whisper model, the only one they have available for speech to text rather than text to speech. So in terms of chat, now this is what you have to know about chat. Let me go back to the class here. The way the chat works, you're transmitting a list of message. So here, let me scroll down to where the chat happens. Create a chat request. Yeah, this is more complicated than it needs to be, but I'm saying you put in a model and a list of messages and arguably a temperature. The temperature is the degree of randomness you're willing to allow. So if you're doing something creative, you bump up the temperature so that you get different options each time. If you want it to be deterministic, you lower the temperature, like put in 0.1 or even 0 to try to get the same thing back each time. That list of messages is important though, because a message, let's see if I can get there. Yeah, it has a role and a string. And role, again, I made an enum. User and system and assistant. Now there are some other options, but I'm going to stick with that. Here's how to think of it, because all of these use messages like this. A system message is context. You are a helpful assistant and who happens to be an expert in analyzing PDF data, something like that. You know, I'm going to ask you questions and then you use this, that, or the other. Whatever you want to put into the overall context. A user message is when you're asking a question, and an assistant message is what you get back. The thing to know about these services is that programmatically, they're all stateless. They're all independent of each other. If you ask a question and then you ask a second question, it's going to not have any connection to the first one. However, that's why you make a list of messages. Like here, what I did is I made a method that put in the model and then message ... And I just arbitrarily made a list and said, you know what? The even ones are the user messages and the odd ones are the assistant messages. Actually, I think I did it down here. Anyway, whatever. And then I submit that. So let me go back to the test again. So that's just a straight question. Oh, I must have it in the Claude one. Okay, let's look at the Claude one, because it looks basically the same again. I got to go to the test class here. And I don't have it in this one directly, but let me show you what I do have. Okay, now, what if I, well, since I did that one, I really ought to at least run it once. So here is, what is the ultimate answer to the ultimate question of life, the universe, and everything? Which I hope that's not an obscure reference to too many of you, although that's pretty dated. You know what the answer should be, right? Somebody? 42. Thank you. I appreciate that. And the answer I got back is the ultimate answer to the ultimate question of life, the universe, and everything is 42, according to Douglas Adams' book, The Hitchhiker's Guide to the Galaxy. When I read that in its first edition, that was surprising. You know, it's like now it's a cliche. But at any rate, what's the ultimate question, right? That's the hard part. At any rate, it works, and that was a user message, okay? Now, if I go to Claude, for example, under Anthropic, then here's my Claude chat. And the funny thing about Claude, actually I have it over here, Anthropic, is that they have a whole guide in how to come up with prompts and everything. And here's the weird part. They recommend using XML tags to separate out information. But there's no schema. They don't say what XML tags. They just say separate it out in an XML tag and we'll recognize it as a separate part. I'm like, you got to be kidding me. What is this, 2002 or something? You know? No, they did that. So for example, over here in my request on one of these, am I on the right one? I want to go to, yeah, well, this one's fine. Look, I say something like, you're a Spring Developer expert, generate a multiple choice quiz. The question topic should be, and you see I'm using a %S in between topic tags. And then down here in formatted, I'll plug in the value. you know, whatever it happens to be. Please use the latest versions of Spring and Spring Boot. And here's the answer. You know, before answering, please think about the question within the thinking tags, or something like, yeah, here, I'll try this one. Here's a Java record representing a person. I just hard-coded something in. Here's a passage of text that includes information about the person. Captain Picard was born on the 13th of Juillet. %D years from now in Labar, France, Earth is given name Jean-Luc. It's of French origin. It translates to John-Luc. Please extract the relevant fields into an instance of the person record. But you see, I used the tags here to separate it. Now, this one is one I use to test a lot of these models, because it'll find, believe me, it's going to find the last name. It's going to find the first name. No problem. It may even find some address information. But that date born, that's going to be a problem, right? Because I'm saying compute it, %D years from now, and he was born in 2305, and I'm plugging in that minus the current year. Now I'm asking these AI models to do math, and the smaller ones are terrible at this. So you see, when I do my assertion down here, I'm only looking for the date within 5 years. Or 2 years, I guess I'm trying here. And we'll see if we get it or not. So let me run this one. And I'll have it submitted and see if I get back. I mean, it should find the names and the titles and everything. And yeah, okay, based on the text, here's a person instance. And they wrapped it in these back-quoted Java tags. So I had to make a regex to parse that if I wanted to get the data out of it. But that looks right. See, there's the first name. There's the last name. Hey, that's the actual date. So what's the problem? That should be fine. It extracted record person? That's wrong. Okay, I'll have to figure out what went wrong with my test, but actually I'm rather pleased it actually got it right. So that was good. So you see how you do that. And if you want to have a conversation, which I thought I had in there, where was my conversation? Might have been in this one with the conversation. No, I don't have it. And we're running low on time, so I'm going to tell you more about it. With a conversation, what you do is you send a series of user requests followed by assistant requests followed by user requests and so on. And that way you can build it up. Now, you're building up a bigger and bigger message each time. But that relies on the context window, and the context windows are getting bigger and bigger all the time. It costs you tokens, but tokens are cheap. Pretty much. I mean, again, unless you're in production with tens of thousands of users. But it's worth it to get the memory part. In a tool like LangChain4j, they have a method that says, oh yeah, set the memory to be the last 10 messages or a certain limit on number of tokens, whatever you like to do. Here, I had to code it myself. That was the only downside. Okay, yeah, I put in the stuff about the pricing I told you about. In the response, there's a usage block which tells you the number of input tokens and the number of output tokens and the number of total. Total's pretty useless because input tokens cost about between a half and a third of what output tokens cost, but they're priced differently. So what good does it tell me to know how many total what I got? I want the inputs and the output. But that's fine. I recommend, again, you create constants for the endpoints, create constants for the models, create enums to help you with validation and make sure you don't accidentally put in something that isn't good. The messages I told you about, there's also a function or what they sometimes call a tool message that the frameworks support that really, really well. Coding that by hand is painful. So I didn't code that by hand. I don't have a demo of that right now. What's the tool support? Actually, let me explain that because it only takes a minute to tell you what it is. There's some things these AIs do really, really badly, like math, basic math. Another thing they do badly is accessing other sites on the internet or something like that. Like I put in a question earlier today. I said, what's the current weather in Bangalore? And it said, I'm just an AI model I don't have access to. You might want to check this site or that site or whatever. So what I did is I wrote a class to access the Open Weather Map API. And if I was using LangChain4j, I annotate a method with @tool, and I put in that @tool annotation, compute the current weather in whatever the location is. And then when you submit your request, you tell the AI, use that function. or that tool. Again, they use the terms interchangeably. And in the straight OpenAI documentation, it will tell you, yeah, here in the output, I want you to call that method for me, and what good is that? But in LangChain4j and in Spring AI, it'll call the function for you. It'll actually do the invocation. And then you get it back, and you get back a reasonable response. And I've done stuff like you give it, here, compute the length of a string. And it's something trivial like that. But by giving it the tool, then you know it'll get it right. So you provide function support for the things it does poorly. And I would do that, but doing it by hand is annoying. Doing it with the framework is trivially easy. So that's one of the things the frameworks bring to the table. At any rate, that's what that function support is down there. Messages I told you about, the enums, you have to put in your own serialization. We talked about that as well. I didn't do any DALL-E image generation, but actually that one's pretty simple because it's got a lot of constraints on it again, but the argument, again, is very small. You're just saying, here's a text description of what I want. Here's the model I want you to use. And you may have a couple other parameters to play with, but that's up to you. The default size for DALL-E 3 images is 1024 by 1024, and I'm usually fine with that. The pictures come up just fine. And the output can either be a JSON block that has a URL in it, but then you'd have to go and download the URL. Instead, I set the response format to, I think it's text. I just say, it's B64_JSON, the base 64 encoded JSON string. And then I get the string back and I just decode it and get to take a look at it. You can only do one image at a time there. Now, I do have my DALL-E model here. That's right. Here's DALL-E, for example. And again, the authorization header and the content type, which I'm sending JSON data and publish it as a string. But this time when I get back the answer, I'm going to decode it from JSON using this image response. And if I go to my test class here, I'll generate one image, not a happy robot. Let's say cats playing canasta. Because after all, dogs playing poker is a cliche at this point, right? So I'm going to make it DALL-E 3. I don't want DALL-E 2 there. And let that one be the last thing that great. What did I mess up here? I shouldn't have tried to edit the one that was there. The return value is null. Okay, I'll just show you the example, which I think I have one in here. Actually, that's a happy jumping robot. So you see, that's the sort of thing you can get out of it very easily. I think the spring one is where I do the cats playing canasta. So, okay. Yeah, there's some bleeping robots. Stable Diffusion has its own API. I've got examples of that in there as well. They tend to look a little better, you know. Whisper audio to text, I already told you about. Remember, you'd have to limit yourself to 25 megs, but I've got a splitter in there and the transcriptions, and I'll talk about RAG more tomorrow. What I want to show you, let me skip forward. They're the repositories. There's the GitHub repositories that you may be interested in. So they're all under my account, so under Kousen. The one called OpenAI Demo is the one I've been showing you now mostly that doesn't use a framework. Whereas the one called OpenAI Client, that's the one that keeps growing and growing. That uses Spring, but not Spring AI, just Spring stuff with auto wiring and the Jackson parser and everything. I've got one for Claude as well. You don't really need that one. I also put one together of examples from Spring AI. Expect this one to change radically over the next few months. LangChain4j may be pre 1.0, but I would say it's worth using now. Spring AI, give it a couple of months, you know? I mean, I'd say LangChain4j is a good 4 to 6 months ahead of Spring AI, and they promised a 1.0 in May, but they promised that before, and we'll see how it goes. Okay, I mean, that's, and I should mention my Tales from the Jar Side YouTube channel. I have an entire playlist on Java and AI together, you know, if you're interested in any of this, lots of demos and stuff. And I'll just finish with, again, Actually, yeah, I was going to have humans and animals and robots working together. The poor doggy on the Roomba, you know. But there's my contact info again. I'll hang out afterwards if there are any questions, but otherwise, thank you very much for coming.